Thank you so much. That's a very nice introduction. All right. So I have a couple of objectives over the next 40 minutes. One will be to sort of orient you to why I'm studying the things I'm studying. I don't assume that people are familiar with this sort of body of my work. That would be very presumptuous of me. So I'm going to spend a little bit of time saying how I got to where I am now in terms of studying the things I'm studying. And then I want to present some new work to you that is not yet even submitted on some methodological approaches to studying within-person change. So just to situate myself like more broadly, I would consider myself to be part of a mid 2000s group of people that includes Omar Lizardo and some other people who were essentially interested in trying to understand how beliefs and values could actually affect people's behavior in meaningful ways. And this seems like a kind of weird thing to have to assert, but when I was in grad school in 2002, 2003, this was a oddly controversial position. And so a lot of what I've spent the last, I don't know, 20 something years doing is trying to think about where these things come from and what they do. Let's take an orienting example real quick. This is the kind of thing I want to talk to you about today. This is from the GSS. This is support for laws against interracial marriage. So this is asking all Americans in the GSS from 1972 to 2002, would you do support laws that would prevent the intermarriage of blacks and whites? And as you can see, the first time this question was asked, about 37% of Americans agreed with this, agreed that there should be laws against the interracial marriage. And eventually this declined to about 10%, and then the question was discontinued from the GSS. And I have my y-axis minimum set to 8% because you can get 8% of people to believe anything. So 8% I think is the realistic low point for any survey question. So how does this happen? My sort of orienting example is, how do things like this occur? There are a couple of competing models. These are sort of ideal typical models of cultural change that we've written about before. The first is called the active updating model, which is that individuals sort of follow the zeitgeist. They're hanging out. They're watching TV. They're seeing that other people are, talking about this. They're seeing that TV shows are changing. They're seeing different representations of things on television and among their kids. And they say, like the world's changing. And they don't say this consciously, but they update their views according to what's going on in the zeitgeist. The second view is that mostly by the time people are, let's say, 18 or 20 or 25, something like that, mostly people's views are settled. And so the real engine of change is that old people are dying. And younger people are getting old enough to answer questions on the GSS. And so they start to form a greater proportion of who we're talking. And so this idea is compatible. And there's a lot of intellectual history here we could talk about. This is much more, active updating is much more focused on things like public representations of culture, thinking about culture as discourse, thinking about culture as sort of available toolkits, thinking about the public elements of culture, like in a Geertzian fashion. Whereas the settled dispositions model is more compatible with things like Bourdieu's concept of habitus, or even going back to things like socialization models of Parsons and Schills in the post-war period. Okay, and yes, before you ask, I am in fact familiar with Max Planck's almost quote that science advances one future all the time. This used to be the question I would get most often, so I just want to head that one off. I have heard of this, yes. Okay. So speaking to a group of demographers, I really don't probably have to talk about this, or people who are at least related to population research. You all know the age period cohort problem. Basically what it is that we have two real variables that we want to estimate sort of three conceptual effects. Now, this talk isn't really fully about age period cohort problem, which is something I've been interested in almost nonstop since about 2005, and I have lots of thoughts on this. This is not totally what I'm going to talk about today, but it's important to understand why I'm going to do what I do today. And there are a couple different approaches that we can take to sort of tackling this problem. One is that we can use repeated cross-section data, and we can use a variety of decomposition. So you'll see me use a hierarchical age period cohort decomposition for the first part of what I'm doing today. I just want to be very clear, I don't think that's a good model. This is just a way of partitioning variance under some very unrealistic assumptions, but that's one way to do it, is to think about it in terms of repeated cross-sections. Another way is to try and think about panel studies of individual change. I mean, all of these cohort models, age effects, period effects, they do have implications for what the data should look like if we follow people over time. And so we can trace out to sort of some of the individual level, person level implications of these models. by following individuals over time. Now, both of these methods, I'm going to show you with survey data today. I've actually done some work with unstructured data. This paper with Ted Underwood in sociological science about cohort succession in literature. So you can do this with unstructured data as well. The stuff I'm going to show you today is using surveys, but the ideas are pretty much the same. Okay, here is the sort of now somewhat classic, somewhat in dispute hierarchical age period cohort model, Young Land model, which to be clear, I think is a bad model for many reasons that I can't get into today, but it's a useful sort of starting point. And so some of my earlier work when I first started this new sort of aspect of my research agenda in about 2015, 2016, was doing this kind of stuff on a bunch of different variables. And we wanted to see basically what is the size of the cohort variance relative to the shared sort of cohort and period variance. So basically, if we want to understand like where the variance comes from in these temporal variables, we don't need to really worry about age when we're trying to adjudicate between something like the settled dispositions model or an active updating model. What we really care about is what the relative importance of sort of period shocks and durable dispositions that people acquire in younger age. And so this was like a reasonable place to start. We did some things with window restrictions and other things in this paper that are not important to go into now. But it turns out if we apply this method to something like this, to RACMAR, the interracial marriage question, about 85% of that change looks like cohort replacement. 85% looks like cohort replacement. So it's really easy when you see something like this, and you see representations like this in the media, and frankly in sociological research all the time, people talk about how people change their minds about those people used to believe this, and now they believe this. And I guess certain understandings of people, that's true. But the implication is that individuals have changed their minds. Whereas for the most part, just from a very simple decomposition, it looks like understanding this kind of change primarily as a cohort replacement thing is more effective. Now, you can have beef with the model, I certainly do, but this is pretty robust to doing this in lots of different and unprovable ways. Okay, now this is sorry for the bad graph. It was 2015, and I didn't know any better. But this is a distribution of these things across 164 variables in the GSS. And this measure here, this delta coefficient, basically tells you kind of how cohorty the process looks. So the further to the right is sort of more cohorty. To the left is more periody. If you want to think about it that way, just from this again, meant to be just descriptive. And so the take home, our sort of take home message from this was that most things are mostly cohort replacement. Now, of course, this was taken to say that people never change and everything is cohort replacement, because that's, when we read other people's work, we do a little compression, and that can be useful. So that's where that came from. Okay. Now, doing that with panel data, and that was a paper with Omar Lizardo from 2016, doing that work got me to start thinking a little bit more about the panel implications of some of these things. Like, what if this way of thinking about the world is true, what should we see when we follow the same individuals over time? Now, some of the problem with this, of course, is that we're following people over a much shorter period. So with panel data, normally you're following people over, like we think of the rotating GSS panels, which is what I use first, you're actually only following people over a 4-year period. So that's a pretty short amount of time. So there are other panel data sets that go for a longer period of time, and we've done some work that uses lots of those. I'm going to show you something today from the British Household Panel Study, but anyway, we've done this with a lot of different work to try and understand what it would look like at the individual level, following individuals over time, to see what kind of evidence there is for individual updating. Now, the intuition behind my first step was to say, okay, imagine you're at like GSS headquarters at North, and it's 2014. And the new data, the 2014 data, the third wave of the 2010 panel is about to come in. The data is about to come in, and you and one of your people who are sitting at the command center of the GSS, sitting on the bridge of North, you say to yourself, okay, I want to predict what every person is going to say on wave 3 of this panel. What is my best shot for predicting what this person would say? Is my best guess what they said 2 years ago, or some kind of average of what they said 2 years ago and 4 years ago? And the reason for that is if people are changing, then what they said 2 years ago should be a better predictor of what they say now than what they said 4 years ago. it's very simple. Like if I wanted to guess your weight today, it'd be much more valuable for me to know how much you weighed yesterday than to know how much you weighed 2 weeks ago, or how much you weighed, 2 months ago compared to how much you weighed 2 years ago. And this is because of how gaining and losing weight works. It's a relatively slow process. And so the question is, how does this look in the case of the general social survey? So this is the first stuff that I did with Kevin Kiley and ASR. This is what this model basically looks like. Essentially what we're doing is we're trying to predict people's responses at wave 3. And we can relax this in various ways, but we're just using a normal distribution. We want to predict what the person's going to say. There's going to be some residual here. And what we want to do is we say, hey, I want to know, there are two parts of this model. Okay, so beta here is the extent to which wave 3 is predictable at all on the basis of previous responses. So here, so you can see beta is shared by both the wave 1 term and the wave 2 term. So beta says this is how predictable it is at all. Predictable. So if it was just noise, beta would be basically 0. And then phi here is how memoryless, like Markov-like the process is. When it's closer to 1, so think about like if phi is 1 here, that means that all I need to predict your outcome is wave 2, what you said last time. And if it was closer to 50-50, then that would mean that both what you said 4 years ago and what you said 2 years ago are both equally good for you. So the sort of theoretical numbers of interest here are going to be something like 0.5, which would mean that it's 50-50. And in theory, something like 1, which would mean it's all about last time. Now, the problem with that, of course, is measurement errors. We don't actually expect this to reach 100% in any case because of measurement error. There's going to be some, it's never going to get to quite 1. But anyway, that's the idea. Okay. So this is the idea. And if you want to know more about this, you can read. So this is just a few of the estimates. These are like groups of variables. We did this for 180 something variables in the GSS. So I'm not going to be able to show you all these, but these are just some groups. 24 civil liberties questions, crime and police, trust, sex, sexuality, and abortion, race, and immigration, gender, and family. Okay. So now 0.5 here, 0.5 is, remember, means that both waves, knowing what they said at wave 1 and what they said at wave 2 are both equally predictable at wave 3. Okay. So if you look here, you can see, and the dot is the median. The dot is the median and so 0.5, gender and family, almost all of them with one exception, which is child should be popular. And we hope people were updating their beliefs on child should be popular. That's sort of interesting. Race and immigration. This question is mostly no exactly. This is like why are whites rich, or why do some white people rich or poor? That's a weird question. But you can see in general, I don't want to go through all of this, but you can see in general that most of these weights are back toward the sort of 0.5 zone. And basically what that means is we spent a ton of money to follow you. We spent a ton of money to do this. And basically what that means is your wave 1 and wave 2 responses are more or less interchangeable in terms of their ability to your wave 3 response. And so what that means is that's not super consistent with the idea that people are sort of learning and growing and changing across these periods. Okay, now, so we published this paper. I gave a talk at UNC, and Ken Boland was like, you should do this with structural equation model. And I was like, okay, let's do a structural equation modeling instead. So this is a different paper that we wrote the following year, which estimated the same sort of basic setup. It's a little bit different, but the same sort of basic setup. The idea here is we have this unobserved latent variable, which is basically your static view across all 3 waves on these things. Like this is just what your position is on like whether a woman who works can form just as good of an attachment with their child as a woman who doesn't work. Like an example of TSS question. And so this is the idea. This is your stable belief. This is your stable belief. And so this is going to predict. This is going to be connected to wave 1, wave 2, and wave 3 in the same way. And then we have this autoregressive parameter here, and this autoregressive parameter says, hey, beyond just knowing basically what this person's average is it valuable to have ordering information? If you want to think about this, what Rowe is telling us here is it valuable to have these 3 observations in order, or if we mix up the order, it wouldn't make any difference. So I want to think about what that means. It means I have 3 waves for you, wave 1, wave 2, wave 3. The model that eliminates Rho here, that sets Rho to 0, would basically be we could just mix up your observations and it wouldn't make any difference. So wave 3, 2, 1, 3, 1, 2. Okay, that would fit the data just as well. And if you look at this, we did some big model comparisons here. And what you can see here is we looked at this in all 3 DSS rotating panels, the 2006, 2008, 2010 panels, which were 4 years each. So we looked at 180 something questions across the 3 different panels. So that's a lot of variable panels. And what we can see here is these are the ones where it was okay to set rho to 0. All of these were the ones that were okay to set rho to 0. So basically, you know, where it doesn't matter that much. This is the one where the big difference was less than 2, more or less just saying this is inclusive in terms of okay, base factor. And then active updating, where it made sense to estimate rho was here, was a little bit here. So again, this is another way, you know, these findings I think are even more, suggestive of the idea that, you know, there's not a lot to learn by following 45-year-olds for 4 years and seeing how they're changing their mind about stuff. That's the average age in GSS across this period. That if there is some, you know, in the process of doing this, and my co-authors, Kevin Kiley and Nico Restrepo, have done some additional work where they look at some of these factors among kids. And among kids, it does look like there's updating going on. If you look at adolescents, for example, it does look like there's updating going on. Why? Because people got to learn this at some point. People got to develop their views at some point. But by the time we get to adulthood, at least, there's not a lot of evidence of a lot of people changing their minds. Now, one of the things you'll see down here, these are a lot of questions about gay rights. So one of the examples that people talk about a lot when I talk about these issues is, doesn't it seem like people have changed their mind about gay rights? And that is actually one of the questions where it does look like people have. That's a topical area where it does seem like people have changed their minds. But for lots of other things, it does not, in fact, seem to be the case. Okay. Now, so in about 2023, sociologist in Germany, Philip Lurch, wrote a paper in ASR where he challenged some of the work that we did, saying that the panels weren't long enough and you should use a different model. And this was I like fighting, number one. And to be honest, I also like learning new things. And he actually had a lot of I learned a lot from this paper. I mean, I don't think our conclusions are much different. One of the things that he showed here was that if you fit like a sort of latent trajectory model or a random growth curve model through like longer panel, you can see that essentially there is variance in those trajectories, meaning some people are on slightly different time growth trajectories than other people. So that got me thinking a lot about sort of random growth curve models and how they relate to this over longer panels. Long story short, that's all true. But when you actually started to look at his estimates, one of the things that we saw was that the average within subject change was about 1/25th as large as the average between subject difference. So if you're doing a tournament of models, which is essentially what we were doing here, if you look at this, what I call the tournament of models, somewhat tongue-in-cheek tournament of models approach. What you can see here is that what this question is actually asking is something like, does it make the model better to estimate rho or not? Which is not a way of saying how big is rho, how important is rho, et cetera. And so so Lurch also did this tournament of models approach and found like, hey, if you specify the models this way on this kind of data, then it does look like there's a lot more sort of updating going on. And that got me thinking like, yeah, that's true. But if we go ahead and we start looking at the coefficients and we start looking at the variances, it looks like that within subject differences, they're not 0, but they're very small. So what we wanted to do is we wanted to start thinking about clarifying the question a little bit. As this debate moved forward, we want to start clarifying the question a little bit. We wanted to move from adjudication to quantification. Does this variable change, like within subjects, does this variable change, to how many people are changing and by how much? And it turns out this is a really hard question. This is actually a really hard thing to measure at the individual level. So we had a paper in political psychology, Turgut Keskin-Turk and Pablo Bello and I have a paper that recently came out in political psychology that showed like in 3-way panel data, it's almost impossible to tell if like an individual person changed their mind about something. Like because of measurement error, even under very realistic or even fairly generous assumptions about that, it's very difficult to tell whether an individual changed their mind about something. Because a lot of like things we look at in 2-way panel data, it looks like what somebody, or even 3-way panel data, what looks like a person changing their mind is just measurement error. You ask me today, I say something, you ask me in a couple months, I don't really have that. I haven't thought about this that much. I make up another answer. And sure, there's something there. It's not nothing. But what looks like change is mostly measurement error. Okay, so we wanted to figure out ways to quantify this. And we've been working on this in a couple different ways. Including ways that just didn't work at all. We have a paper on OSF that was like one of our attempts to do this that ended up being basically a complete failure. So this is our new way of doing it, which we think is a success. And so this is with Kevin Kiley, who's the first author on this work. He's an assistant professor at NC State. Turgut, Keskin-Turk, my PhD student, Anaki Middleman at Sciences Po, who's a former postdoc of mine. We're working on this, and I'm just gonna. So what we decided to do is think about this from the lens of prediction. And what we wanted to do is say, if we wanted to actually, because remember when I showed you the meme, I said the idea was we're sitting at North headquarters and we want to predict what's going to happen at wave 3. The reality, though, is we just use like model fit, like penalized likelihood model fit criteria to do this. We didn't actually predict. We didn't actually like say, let's pretend that we don't have the wave 3 data and see what happens. That was the sort of way that we oriented the example, but we didn't actually do it. So what we decided, and this is Kevin's doing, he was like, why don't we actually predict? And so what we did here was we used 20 questions from the British Household Panel Survey. And one of the reasons we use the BHPS is because we have a lot of questions, about 20 questions, I think, that were measured at 8 waves. They're measured at 8 waves between 1991 and 2009. And so we have a lot of people, number one, and we have them, we get them to answer questions a lot of times. And one way to do this is to basically say, okay, we're going to go through, each person has 8 responses. We're going to go through, I'm simplifying a little bit here because I'm missing data and other stuff, but each person has eight responses. And what we want to do is say, let's just take one out. Let's just take out one of the responses randomly. So this hollow circle here, we're going to take that out. We're going to estimate that our prediction for that hollow circle is going to be the mean of all the other responses. And if people's responses are just measuring it, then this is our, like, if what looks like real fluctuations is actually just measuring it, then this is our best approach. Our best approach is just to take the average of the 7 other observations and use that to predict the health out observation. Okay. As opposed to something like this, which fits through some method. So it could be, it could be a fixed effect. It could just be give the person their own slope, like in a fixed effects type setup. We could do random slope, partially pooled slopes on age. We could do partially pooled slope on wave. We could do a partially pooled quadratic slope on wave. We could do a partially pooled. So there are a lot of options about how we could fit this in. But let's say we fit some kind of time thing here, and we say, all right, if we take these 7 points and we try to fit some kind of time slope through here, how well does that predict the held out response? And you can see in this case, the held out response would be predicted better by the one with time. Okay. And the idea is that we're going to do this. So every observation for every person, so each of the 8 observations per person is going to get used as a held out observation on sort of a loop through this. We're going to loop through this. We're going to do it's basically k-fold propagation. We're going to do this. And what we're going to do is we're going to quantify at the individual level, how much better is this data point? What is the size of the residual here as opposed to the size of the residual here, which is something that we can calculate at the individual level. So you can say, what's the error that we estimate for that person if we just use essentially between subjects or baseline information? So we just use the average of the 7 observations to predict the 8. That's this. And what is the size of the error here? And then we can say, all right, and how big is it when we allow the person to change? How big is the error when we allow the person to change? Okay. So this is how we do that. We can normalize it by variance of y. And we call this incremental predictive gain from change. So incremental predicted gain from change is like how much of a difference does it make for that observation? And we can define this at the individual level, which is not something that we've done before because we've been using model fit statistics, but that's something we're going to do here. And we can aggregate this up by basically saying, hey, what is the sort of predictive accuracy of the change model minus the predictive accuracy of the baseline? So essentially, how much does it improve the fit in the aggregate if we allow people to change, as opposed to if we just assume that everybody over this essentially 19-year period is not changing their mind. So basically, every time they're just telling you the same thing with error every time. Okay. All right. So let me show you 2 examples. This is the most extreme, and I'll walk you through how these pictures are going to look here. So this gray bar, so this is R squared. This here is the baseline model. This means for this question, how well does using the 7 observations to predict the held out observation, how well does that predict? In this case, it's not very good. It's about 13, 14% of the R squared. So this is a very noisy measure. It's a very noisy measure. And what this dashed box says is what is the best fitting model that allows for change? And these models are all the different ways that we specify the change models. So this is like random effects. We're using wave as time, and a quadratic. So essentially we're using wave, not age, but wave as time with a quadratic functional form. This is just using an unstructured covariance. This is using the random effects wave, but assuming that the thing is linear. I won't go through and read all these. We did some other shit like change point analysis, this kind of stuff. We went crazy. Okay, all right. And one of the things you can see here is that some of these are actually worse. Do you see what I mean? Like this, like using fixed effects wave, like basically we're gonna give each person their own time slope, like makes it worse because we're overfitting. See what I mean? We're overfitting the data when we allow within subjects fixed effects, just no pooling estimate actually makes it worse. So this is the baseline, and this is how much better. And so you can see here that the incremental gain is about 13 percentage points. Now, one of the things is because we can define this at the individual level, we can plot it against something like age. Now, of course, you wouldn't want to take it seriously for any individual person because it's just that's a little extra. But we're not going to do that. But one of the things you can see here is how much does it help to allow change at different levels. So this slide is basically in the aggregate, how good is it? And this says, okay, is it better? And what you can see here is people who are older, it matters, it helps a lot. For this question, government reflects the will of the people. Now, one of the things here, this is a classic example of a question where the referent is changing because who the government is here is not static across time. So is it really a person changing their mind? Like if you said, I think the executive branch is shit in the US right now, and a Democrat wins the election later, you would probably not say the same thing. And then did your mind change or did the target change? So this is an example of a situation where the target is changing also. And what you can see here is like, hey, it looks like older people are paying more attention to what's going on in politics in terms of their evaluation of the government. Okay, you can see a little bit. Anyway, so that's an example. Okay, now let's look at a different one. Let's look at a different one. Example 2. It's the government's responsibility to provide jobs. So here's what it looks like. When we let it sort of be the health, we just use the 7 observations to predict the 8. Here it's about 48%, 47% of accuracy from the baseline prediction. And then the best model that allows time just adds a little tiny bit. So that's like a little tiny bit. You can see there's not a huge amount of difference here. Not a huge amount of difference. Again, the fixed effects, we're overfitting here by letting each person have their own. No pooling slope, that's just too much. The change point models, we were very excited about at one point. Garbage. So all this kind of stuff. So this was okay. So we did that. And you can see. So these are kind of 2 bookends of examples of how these things work. You can see the time thing here. You can see, yeah, it helps a tiny bit more for young people. Like it looks like young people maybe a tiny bit more updating their residuals. Like it helps their residuals a little bit more to allow them to update. Whereas as they get older, it goes down. But you can see that in general, it's not helping very much. Okay, so now what I'm going to do is I'm going to show you like 20 more of these. And I'm not going to allow you to really like look at them too long. We're just going to point out a few things here. So this is the first batch, or I guess this is the first batch. And so what you can see here is there's interest in politics, husband should stay home, husband should earn, wife should stay home, single parents, you can read. But anyway, what you can see here is the incremental gain from change is very small in all of these. It's very small. So the first thing to notice here is how much would it help to allow people to change their minds if you were trying to predict a held out observation? And what it turns out is not that much. What that means for the value of doing panel studies of adults who are not going through a major transition, I will let you reflect on as a separate exercise. But what it does mean here is it does not seem like we're getting a lot of traction on people actually changing their minds. Now, one of the things you can see here that's also quite interesting, these are the age profiles. And we could aggregate these by different things. We could aggregate this by education, we could aggregate it by gender, we could aggregate it by lots of different things. We just age is kind of the hero because of this sort of sensitive periods argument. So like knowing nothing else, we should expect in general, younger people should be affected more by allowing them to change than older people. And you do see some that look like this. Interest in politics, it does seem like some younger people are changing, either increasing or decreasing, they're changing. Husband should earn, wife should stay home, you can see that here. Single parents as good as couples, you can see that here. Now, one of the things you can see, and this is not the first time we've seen this, it's the first time preschool child suffers if mother works. You can see people changing, younger people again, forming their views here. But some of these things, you see these peaks at the end. Or you see them as like sort of horseshoe line, where it looks like, and we've seen this we've never published anything about this, but using other methods, we've seen this before, and we've been a little bit puzzled by it. Like, oh, it looks like over 65s they look like young people. And I think it might be just they have more time on their hands. I think, anybody who's in their 30s or 40s, 50s, you're in kind of a tunnel. You know what I mean? How much you pay, and you're just trying to get through life. But you know what I'm talking about. Okay. Yeah. And so the idea here is that I think that there's not a lot of attention in the middle. So one of the things that developmental psychologists and things want to think about is that there's a sensitive period aspect. And I think there's no question that there is some sensitive period aspect. However, there is like a life course aspect of this as well. There's a life course aspect about this too that is not something that developmental psychologists think about. So there's that. Now here's a bunch more of these. So you can see, private enterprise solves economic problems. You can see, again, that's older people are the ones who are actually thinking about that. Divorce better than unhappy marriage. That's again something that seems to be formed earlier. Husband and wife should both contribute. One of the interesting things about this is a lot of stuff that's about like government seems more labile than you can see this pattern here. Again, it's this British household panel study. It's not the whole world. It's one place in time. One of the things you can see here is it does seem like stuff about gender roles, family is forming earlier and then sort of staying put. You can see that in the age profiles quite a bit. I don't want to go through all these. Like, yeah, children need fathers much as mother, same idea. This one is interesting. Adult children should care for parents. People start to have opinions about that again at the end, which really makes sense. Anyway, I don't want to go through all these. Okay. All right, so this is the idea, okay, and this is like hot off the press. We have not even submitted this anywhere yet. Okay, so what are some conclusions? Okay, first, it's important not to confuse cultural change with individual change, and this is like even among those of us who know better, it's a temptation. So when you see overall distributions changing, don't assume this is like people changing their mind. This has a lot of implications for the ways that we want to try and do persuasion. It also has a lot of implications for who we want to study. I think if you want to study people changing their minds, we should be studying children and adolescents. We're doing a very shoestring budget study in my lab of 10 to like 9 to 12-year-olds, basically in North Carolina, and looking at their formation of political ideas. It's a mess. It's very expensive, and we don't have any money. So that's not generally a recipe for success, but we are finding some things. We miss. So I do think one of the upshots of all this work is we really need to study people while the dough is still not set. You know what I mean? While the clay is still a little wet, we need to investigate that a little bit more. Okay, not that it's all developmental, but I think there's a pretty strong developmental aspect. Okay, two, most, but not all. Don't go away saying I said Steve says there's no people never change their minds. That's not what I'm saying. But most, not all, recent cultural change seems to be cohort replacement. So if you need a default model in your mind, again, the world is more simple than this, or more complicated than this. Even more simple. No, the world is more complicated than this. But if you need a simple representation to walk around with about like how most cultural change occurs, it is cohort replacement. That's like a good starting point. Okay. Social salience can override this. So it's not just like, as I discussed, I don't think it's just sensitive period. I think there are times when things become salient. I think the gay rights example is an example of this. I think if you can get a society to think about something together for a long time, they can change their minds about it. You can make it salient enough where people will change their minds about it. I don't know enough to go into this too much more, but one of the things that's a very interesting finding in that we can triangulate across a few different approaches is that questions about the morality of homosexuality, which is a question that's been asked in the GSF, that looks like cohort replacement. So if you ask people like, is it okay? Is it morally acceptable for two adults of the same sex to have sexual relations? That looks like cohort replacement. But gay rights questions look like individual change. And I think one of the reasons for that is like, well, no. So one of the things that we see there, and again, I haven't written a paper about this because I don't think we have the right data, but one of the things from looking at a bunch of different things over and over again is you see this kind of pattern where people seem to be like, look, I'm not into it, but people should be able to do what they want. And that's kind of the cultural consensus. So I think that's a situation where you can see salience can override the situation, not just a sensitive period. Okay. We need quantification, not just adjudication. I think our sort of initial debates, like, does it help? Do people change? That's great and all. It's like, it would be like, but it would be in a way equivalent to saying like, is there genetic influence on it? It's like, yeah, that's not, at one level, that's no longer the interesting question. Like, is there or is there not? It becomes a question saying, well, how much, when, for whom? Those are the questions I think that we need to understand much better in this domain. And new data sources, I'm excited about this to some extent, like unstructured data sources can be useful for this. And I mentioned this briefly before, but we have a paper where we follow authors over time. So we use with Ted Underwood in sociological science, we use all English and fiction between I can't remember what it was, 18 something, 1850 and 1980 or something. I can't remember what it was, but it's a while ago now. But we could follow authors and basically treat that like panel data. And we could also do things like look at the repeated cross-section decompositions. And again, and even in those kind of data, it does look like, and we can go back further into time and stuff like that. It does look again like a majority, not an overwhelming majority, but a majority of the change in the things that we can measure does appear to be changing by cohort replacement. So new data sources may help with this, but they bring other problems. They bring measurement problems. They bring all kinds of conceptual problems as well, representativeness problems, lots of them. So anyway, those are my conclusions. So with that, I will say thank you for your time and I welcome your questions.